eet105, chapter 10, capacitors. Problem number 21, I did the every circuit example for this problem. It's a charging phase problem. So we have this circuit here. I built this circuit and every circuit here. So the blue is going to indicate the current flowing through this capacitor, and the green is the voltage across the capacitor. So I'm going to go ahead and run it in transient space. I already set the time interval accordingly. That's this one here. So I'm going to turn this on, and you're going to see the voltage jump up. So the capacitor's charging and the current jumps up immediately. I'm going to pause it right here. So this interval right here is a 20 millisecond interval across this bar. And you could see that the current immediately jumps up to this value over here. If you click on this, it'll tell you what the maximum is. Here it was 17.1 milliamps. So it jumps up here and then it decays down to 0 over 5 time constants. Likewise, the voltage will rise up to 100 volts because that's that's the way the circuit is set up. Eventually this will charge up to an open circuit, and it'll be at the same value as the DC power supply. So here's the every circuit version of this, and I put it in over here. It shows you the graph. It agrees with this graph solution from the book. The current's a little bit higher in the book, the initial current, but it's pretty close, and you could see that tau is 5.5 milliseconds, and so 5 time constants would be about, what is that, 21, or I'm sorry, it's 27.5 milliseconds. So 5 tau would be somewhere around here, and as you could see, the current is 0 here, and the voltage is basically 100 here. Likewise, for problem 26, I set up this circuit and every circuit. So you have the charging phase was step 1 when this is a single pole 3-throw switch, and in the first throw it's going to be basically an RC circuit. So it's going to charge, this capacitor will charge up, and then in the second throw it's basically charged, and it's in a state wherever you put it into position 2, it'll stay at that voltage and no current's going to flow. And then position 3, it's going to be in a discharge. So I'm going to show you. Here's the circuit I built in every circuit. I had that every circuit does not have a 3-throw single pole switch. It only has double pole or double throw, I'm sorry, single pole. So I had to use 2 switches like this to do that simulation as 3. So if we turn on the timer and then flip it to position 1, you can see it's charging up here. You have your green is the voltage across the capacitor, the blue is the current through the capacitor IC, and then orange is V sub R2, which is what the book called V sub R2. So this voltage, the capacitor voltage, charges up basically the 30 volts, and you can see that value right there. And then when you click on here, you get the maximum. It was 5.53 milliamps that it hit, and then it decays down to 0. And then this maxed out at 11 volts, and then it decays down to 0. So it pretty much agrees with what the book said. this was V sub C in this phase, and then I sub C in the initial phase, and then VR2 in the initial phase. So you could see that they're basically the same thing. So the next step is I'm going to put it into position 2. So I'm going to keep going. This is position 2 right here. It does nothing. It doesn't change anything. And then when I flip this switch, I'm going to go into position 3 and it'll be discharging. So there it is. And you see that that voltage goes down to 0 pretty fast across the capacitor. The current actually flows in the negative direction, um, meaning that this arrow is indicating the positive direction. It's going to flow this way, like is shown in the book. When you go in the the discharge phase, um, I sub C goes negative because we defined the book defines IC in a clockwise direction here. So when it goes in the other direction, it's going to go this way in the counterclockwise, and it's going to be in the negative direction as shown here. I put both phases, actually all 3 phases right here, all 3 positions of the switch as shown. So that is that problem in every circuit.